And we should be live, folks. We should be live here. God, these headphones are cold. What is going on with that? Trying to figure out. Okay. So, everything's looking good. Stream is on. I'm trying to. It's not showing up on the control panel here. So I don't know if anybody is watching other than me because I'm just monitoring. But that's okay. Be nice and relaxing. What? Okay. Anyways. So, this is the first live design session since the video dropped. And some people might be expecting me to do some more instrument stuff. I'm in between projects right now, so I'm just working on figuring out what the next project is going to be. I've got a lot of ideas in the works that are all kind of started in different stages, but I don't know. I'm just waiting on some confirmation from folks to figure out what the next video I'm actually going to be working on is. So I don't want to start something on here that will require multiple streams. So I figure there's a few things I need to do just on personal terms I'm not going to make videos about, and figure we could just go through that. It'll be a little bit of a design session. You could see kind of how I approach designing things, functional parts for other people. So what I've got here, let me just grab it quickly. So one of my friends is he has a Vanagon, the Volkswagen Westphalia camper bus things, and it has these really old. These are like access ports. So I think this one is where the plug goes, and it's got this metal pipe on here. And then this one's similar, but this is for applying a hose so you can get some water pressure. And then this one's actually for filling a water tank, and this one has a door. They're all supposed to have a door. So I told him I could 3D print him new ones because these ones are breaking apart. They're very old. And I looked online to see if there were parts for this already designed that I could. So I'm going to design them from scratch. Oh no, I've gotten crumbs all over my computer here. That's always a good thing. Oops. And yeah, and I think this will just be a nice, kind of fairly quick little project. I could probably model these up for the most part, but there is some design challenges with this. So we're going to have to talk a lot about design for 3D printing. I'm going to be printing this out of ABS. I think that's just kind of a nice material for this. And I'm not obviously there's metal parts on this that I'm not going to try printing, but we're just going to try sort of including them into the design so that we can just take these metal parts off and put them into the new version. So that's the plan. And probably going to save this. This is the most complicated one. This is the one that provides hose pressure. So I'm going to put this aside for now. We're going to work on this one. This one's the easiest one because this one's for the outlet. So this is how the Vanagon gets power. And luckily, it looks like everything that is electrical happens inside of this metal tube, which is just simply bolted onto the front. So this will be the easiest one to design by far. So we're going to do that first. I need a screwdriver. I was hoping I'd have a screwdriver here, but I don't think I do. Oh. Wrong type. Okay, give me 1 second. You'd think I'd have a full set of screwdrivers in the studio, being somebody that builds stuff, but I don't. I just have a flathead, and this is a Phillips, but that'll work for this one, I think. Maybe not. Yeah, all my tools are in the actual shop, like the wood shop, so I don't tend to do a lot of actual like hard building in here. It's more just printing in here. And you do need screwdrivers for printing, but sometimes, but not really. Okay, sorry, this is not interesting content, but that's not all content has to be interesting. Oh god, this sucks. It's a very rusted screw, so we'll probably want to get some new screws. Aha! I do have... See, this is a functional shop. I'm doing this down here because I don't want to get rust on everything. Okay. So, here's the metal pipe, and this actually has what appears to be a busted rivet on that, so we'll drill that out later. But that's not a big deal. Now, I'm noticing there's some extra screws in here. I wonder if this can come apart even further. So here's what I'm thinking, right? This shape is fairly 3D printable. It's quite simple. But you'll notice, like, it would be so nice to print it flat on this surface, but we've got this piece that bulges out. So I want to do this in two parts. Basically, I want to split this right down the middle here, essentially. So then you'll have two halves that go together, and then when it's bolted onto the frame, it should work out nicely. But there's these other screws on here that I want to take off because it looks like... Hold on. Looks like it might kind of already separate like that on its own. And for anybody watching this, just want to say thank you so much for the support on the last video. That thing took me so darn long to do. I want to keep doing stuff like that, but it's also like not it's not a sustainable thing. So I'm going to try and like come up with simpler projects, probably break them into chunks, because I could have done like 10 videos on that one video, but I didn't. So okay, those screws actually do nothing. They must have been there to hold some sort of other panel on, which I don't have, but that's okay. So I'm just going to start by taking some measurements, and we're going to get kind of the basic shape down, and we'll just try and recreate this as close to accurate as possible. And I think we'll kind of just model this. We'll kind of just model this exactly the same for now, and then we will do the kind of split thing after, because I think that'll be pretty easy. Okay, there's a screw in here, which is going to be hard for me to take off. So, calipers, this is the #1 tool I use for measuring things like this. They're super accurate. You can see I'm cleaning the dust off of these teeth because this will actually measure like dust. So we don't want to measure dust. Okay. So now when measuring this corner's broken off. It's actually adding a little bit of size to this. So I'm going to measure this side, which doesn't have the broken thing. And that'll get us... Ooh, these calipers might be too small for this. Because I can get this orientation fine. So what, 109.7? I feel like we could probably get away with 110. And when I say get away with, I just mean like sometimes I like to just round up, especially when it's something like this where the actual size of the thing isn't necessarily super important. But like at 110, it just feels nicer. When we're talking half a mil, I'm fine with that. So, oh yeah, so 110 and then the longer side, let's hope, oh yeah, I got this, folks. So 110 by 120. by 123.6. So I'll go 124. Right, so always start with a sketch. We're going to go top down on this. And center rectangle. So 110 by 124. Boom. That's our first measurement. Okay, that's looking fine. I need a good way to get these angles right. But I think this will be, yeah, because that's a little less than 90 degrees. We'll just start with this, and let me get a thickness here, and then we can extrude this, and then we have a sort of a thing to build off of. 7.1 mils. The thickness is where I'm going to be, like, try to be as accurate. Okay, 7 mils. Just kind of shifting it around. I'm getting like an average of 7 mils on this, on the thickness of this. So we can finish this. I can extrude this 7 mils. Boom. There we are. This is the start. I'm going to save all the filleting and whatnot for after. But you can see this isn't perfectly vertical, right? There's a little bit of a taper there. So I think we're gonna, oh, we got somebody here. Hi, Depressed Banana Bread, how are you doing? So I want to get that taper because I think that's going to help with like water shedding, because this is an exterior, this is an exteriorly mounted thing. So let's get that measurement as well. Thanks so much for being here. So I'm in between video projects right now, and I don't know exactly what the next video is going to be yet. I've got a few things lined up, and until I know exactly which one I need to start on next, I'm just kind of like working on a personal project here. This is for my friend's camper van. Just these pieces. So I told him I'd reprint them for him. So we're just doing a bit of reverse engineering today, some design process stuff, specifically for 3D printing, because I'll be 3D printing these. So yeah, yeah, feel free to hang out and kind of see how I go about this. But really appreciate you joining on. That's really cool. Okay. So I think what I'm going to do, I'm actually going to get these hole locations as well. And now these are clearly, like, I'm dealing with a pretty rotten part here. So I'm going to have to kind of be careful with what I'm actually referencing for my measurements. So these corner holes, I think, are added after because these ones probably stripped out. So I think we'll find a better way to reuse the original holes instead of using those new ones. And we'll just ignore those new ones. And I think I can be fairly, like with stuff like this, screws have like quite a bit of leeway to them, so we can kind of like eyeball this to an extent here. Looks like 75 mils. And like you can kind of assume that manufacturers of parts like this were being round with the numbers, because it doesn't make sense for them to do like 75.33 mils. So assuming they were like kind of like using round numbers, we can probably assume these holes are spaced at 75 mils apart. So we're going to sketch on top of this. And then I also need to know how far the holes are from so I'm just going to get the hole to the edge measurement here. I'm going to take the measurement from the back because there is that taper, so there's nothing on the front to really reference properly. And that's 7 mils. So we said 75. Measure twice. Yeah, 75 by 7. So knowing that, probably what I'll do here is I'm just going to get a center line going through here. And then I can do a little rectangle from this point. And I can make that 7. And then I can go 75 divided by 2. Boom. That will give us, so that means this location is our hole. And then we can just mirror that. I could just mirror the hole as well, but and we can kind of assume it's going to be the same on this side, but we can't be sure. So let's do a quick little measurement. This one's a little harder because the plastic here has deformed around where the screw is. So I want to reference like this edge, which is perfectly flat, instead of this bubbled out edge. So I can kind of use the length of the jaws to help me with that. Line it up here. So this actually looks like it is a bit further than 7. Like it's like closer to 9 mil, which is weird. But that might be right. Let's go with it. So it's 9 mil, and then I'm assuming this is going to be the same. These are going to be 75 apart. They look in line to me. We'll just double check. Yeah, we're solid 75. So 75 and 9 this time. So we'll go 9 and then 75 divided by 2. Boom. And then the actual hole size, we can be fairly approximate with this because hole sizes are pretty standard. 4.5 mil. So we can go 5, boom. 5, boom. I am just going to delete that and then mirror the holes only. Okay. Boom. This is messy work. I don't enjoy how much dust is getting on everything, but it's part. This is Fusion 360. So I believe they have a free plan. They're constantly changing how they're offering this. I was on a free plan for a while. I bumped up to a more expensive version. It's still a hobby version, and it was like negligible. I think it was like $250 for like 3 years. Don't really love anything that's subscription based, to be honest. I was sort of like, I have a CNC machine as well, and this is the only program that could also run my CNC machine while also doing the design stuff. So that's why I'm kind of like locked into this program. But ideally, I would much prefer something that you either pay for it once or it's free. So I don't you know, I obviously recommend this program because it's just the one I use, but there's tons of other stuff out there. There's like Onshape, which I think is a really good one, and that one's 100% free. The only issue is you can't, like, all your designs are public, which is kind of a weird thing. And then I don't know what SketchUp's like these days, but design software is kind of a little bit more premium than most other software out there. I'm not sure if there's a good free option other than Onshape. But they all kind of do the same, and I've used other ones, and I find that once you kind of learn the principles of one, you can transfer over to another one pretty easily. Hotkeys are going to be different, and like the user interface is going to be different, but for the most part, the principles are the same. Okay. So now we can get our holes locked in here. Boop, boop, boop. Okay, now let's get this chamfer correct. So I want to get the chamfer on these edges here. But there's also a fillet around everything, so these little round bits. That's going to make measuring it really hard. So I'm not too sure what the best way to do this is. I think I'm just going to, because obviously it doesn't have to be perfect. This is not, this is not a mechanical feature of this part. So I can kind of just like eyeball it. And I think the goal, because of that fillet, doesn't give us a specific sharp edge to reference. But it's looking like the approximate angle of that looks like it's about a 2 millimeter slope on that. So let me show you here. Basically what we can do, the height of this is 7 millimeters. So if I want, I can take a modify, I can do a chamfer, and I can click all the top edges here. You can see they light up in blue. Boom. And then normally a chamfer will just give you a 45, but we don't want a 45. We want a 2 distance. And I know the height is already 7, so we can make that 7, and that'll get us right to the bottom. And then I just measured that we're going for about a 2 millimeter chamfer there. And so that gives us probably a very similar angle on this edge here, and that's going all the way around. And we're going to add the rounded fillets after the fact. Okay. It's kind of hard to figure out where to start on working on this part because it's off at an angle. But I think what's going to be the easiest is kind of like build a block that comes straight up, and then we'll sort of carve out this angle after the fact. That's probably the best, I think. The other, you know what is also a really nice option for stuff like this, and I might, I'm just going to do this anyways, because it really helps with like the details that are really hard to measure. So I have this app called Scaniverse, and it lets me do a mesh scanning of a small object. So you can see it's just like a camera app. And so I can put this on the table here, and I can just start scanning. And we're going to move the camera around. And it kind of keeps track of where your camera is. And I did this on the ceiling fan video if anybody watched that one. That's how I got the piece to fit on the ceiling fan, right? Okay. So you end up with something that looks like this. But then you save draft. And then you can grab it and you can process it. I'm just waiting for it to process. It takes a little bit of time. Basically, I'm just going to like have this image underneath my design, and then I can sort of reference it whenever I'm like struggling to find an angle and stuff, because I don't think it's gonna be very easy for me to get this angle. Okay. Save. So now I can share. So you end up with something like this, and you can actually move this around. Right. Picked up my keyboard and everything, but I'm only worrying about that. So now I can share this. Export model as an, I think it's an OBJ. I'll do an OBJ. That's what I've done in the past. There's an FBX mode that apparently is better, but share it to my computer. Nice. Okay, I'm just gonna minimize, or not, I'm just gonna exit full screen on Fusion here so I can open up my Finder window. You can't see this, but it's there. Okay, so now we can insert a mesh. Okay, so it's in there now. I don't know why this is so small. Sorry, give me 1 second. So supposedly it's in there. I'm not seeing it yet, but usually we have to scale it up or down. It depends. Okay. I haven't done this in a couple seconds, so I don't exactly know what's going on here. Okay, so interesting. So I scan this to be a millimeter size, but for some reason when I go to meter, that seems to be the right scale. So something's wrong with my scaling in either the Scaniverse or this, but that's okay. So now you can see it right there. Yeah, there it is. It's rough, right? So we're not gonna, like, obviously, like, a lot of people want scanning to be able to directly scan a thing and then just throw it right in your printer, basically. We're not doing that here. This is just purely to get some approximate angles and stuff. Now what we're gonna have to do, I should have scanned this in flat, but the part doesn't sit flat on a table, so it's a bit hard. But what we can do here, we can see this is our edge, and this is our model here. So we can kind of line those up as close as we can get. Right, you can really use the lines of the model, so we can get this as close as possible. It loves to click into orientations. There might be a way. Yeah. Oh no, it doesn't want us to do that. I should also preface this video. I'm not like a pro at this. I don't have any training in this at all. I'm entirely self-taught on this software. So if you have any tips for me, I'm all open. But you can see how this is getting pretty darn close here. Yeah, make sure we're in orthographic, so we're seeing it dead on and no funny business. Now we can kind of line these guys up. I'm noticing this side didn't really capture the scan too well, so I'm going to be using mostly this left side to reference, and the angle's just slightly wrong, but I don't think I can get it. Like, why can't I type in a number here? Just hit OK on that for a second here. So you can see it's fairly close. We're a little off in certain areas, but now I should be able to move it again, and we can fine-tune this. So one of the things I'm noticing, it's like slightly skewed here, so we can turn it. Yeah, so now that I can move this, or now that I've moved this again, you can see how it jumps from 0 degrees to 2.6, and that's like not doing it. So we can type in our degrees instead. 1 degree looks pretty good. Let's try 1.5. Oh, 1.5 is not bad either. 1.4. 1.3. Let's go with 1.3, and then we can kind of shift this in. We can line up our holes a little better too. Didn't really pick up the holes too well, but that's okay. We've already got those. I feel pretty confident about that. Right, that's not too bad. And then this angle actually looks good now that we've skewed it. Yeah. So we're just going to hit OK there. So there's our scan, and then we can just disappear it when we don't want it, which is going to be most of the time. Now, oh yeah, see that hole's like right on. basically. This one is weird, but I think we're going to be fine. We're going to be fine. The model might be, or the scan might be slightly bigger, but that's okay. We can scale as well. Let's try just scaling it down the tiniest little bit. Oops. 0.99. See, I don't really see where the holes are. So we can kind of toggle. And this is just like initial setup stuff. Once you get all this, it becomes a lot easier. So we can toggle the body to see if the holes are lining up. You can see the hole there. It's close. The hole there, it's close. Turn my sketches off here. I think we're going to be good for the most part. Maybe I'll scale this down even smaller. Let's try 97. Oh, that was quite a bit. Let's go 98. And I'm just seeing like how close are my holes to those holes. And we're off a bit, but we're off kind of in the same amount everywhere. So let's hit OK. And then let's move the mesh again. Yeah, those holes are lining up pretty good now. I think we could actually do one more rotation of this, like 1 degree. No, that 1 degree was too much. A lot of fiddling. Lot of fiddling. Minus 0.5. But once we get this, it'll make it a lot easier. So that's looking pretty good, I'd say. And like, we're not going to rely exclusively on this mesh. It's a reference mesh, right? So I'm not going to be using it to, I'm not just going to trace out this design. I'm going to use it as a reference entirely just to make sure my measurements aren't like totally off. And it'll help get some angles and stuff. It's important to understand what the part you're making is as well, because I know that these dimensions aren't necessarily like super important to the functionality of it. So in that case, this works well, but it's not always the best way to go. Okay, so let's turn the mesh off again. You know what? I totally did mess up though, because these top holes, these are the top holes, these are the bottom holes. These are like 9 millimeters from the top. These are 7 millimeters from the bottom. I have them backwards. So what I'm going to do is I'm going to go back in my timeline. This is one thing I love about Fusion, is you can go back in time and fix things. So you can see this is 9, that's 7. We're going to make this 7, and we're going to make this, remember to hit enter, folks. And then we're going to make this 9. Now it is making me think that maybe and actually that does kind of fix this, because you can see the mesh here is like a little bit past our model, and then here it's like not past the model. So now I can actually shift this mesh down, and hopefully it'll line up even better than before. Oh yeah, that's looking pretty nice. Right, that's looking decent. Okay. So now let's get this sort of bump out feature going. So once again, this is a tapering thing, right? It tapers sort of like that. It's not vertical. Oh my gosh, so hard to show this on camera. It's not perfectly vertical. It's got a bit of a taper to it. So I'm going to measure the base, and that's where we'll start, and then we'll taper it in after. Once again, calipers. It's cold in here today. And everything on this is like a little bit rounded, so we can only get so close, but looking at like 108 on that. And then we're looking at, what is that? 77. So here's what we're going to do. We're going to just create a sketch here. And we're going to go with make sure I have my orientation right. That's the bottom. Yes. We're going to go 77 and 108. Delete these references. Actually, I'm going to not do I'm going to do a regular rectangle, because I don't know where in space this exists yet. So we're going to go 108 and 77. And you can see now we have this rectangle that I can freely move around, and that's exactly what we want, because, well, we know it's centered this way. And so what I can do is get a line going like that, and then we should be able to coincident this to the center here. So now this is a centered in the horizontal direction, but I should still be able to move this up and down. It's not letting me, but that's okay, because we can just delete this middle line, and now this moves again. But I'm going to undo, and I'm going to do a move. I'm going to be able to do a move function and move it in just the y-axis. So now I need to know what the distance from this to this is. We can go from the top of our chamfer this time. It's looking like about 12.5 millimeters. And so we can use the sketch dimension tool, and we can get this to about 12.5. Boom. And that should be where we want it. Right? So now we've got this square here, and we're going to be extruding this up. Now I need to know how tall this is, and I can't measure the length of this because this is at an angle. So I have to do a straight measurement, and the calipers have this great like plunge feature. So we can get that. It's important to stay fairly straight on this. I'm getting about 18 on this. And we'll turn the mesh back on. Toggle this. You can see, look at that. That's where the mesh ends, and that's exactly where we want to be. So now we want to worry about the angle. And this is where I'm going to use the mesh, because this seems more like an aesthetic choice and like just like a water shedding choice and an aerodynamic choice potentially. So we can go like this. We know this distance is 18 because we just did that. So it gets us right to the ground. And then what I'll do is I'll just pull this, and I'm going to go to the back side here. I'll just pull this until the angle matches up, which is going to be like right about there. Right? So we're following the mesh there. That's fine. And then I'll do the same on this edge. Once again, vertically, we are sitting at 18. And then horizontally, we're going to follow the mesh. So right there. And you can see it's like slightly off here. So I'll need to kind of verify why that is, but I think it should be fine either way. That's looking good. And then lastly, we'll do the same for this big chamfer here. So we want to go 18. This goes right to the floor. And then we'll take this. And if you just drag it straight over, you can see how it starts to reveal the mesh. I keep pointing at the screen thinking people could see the screen, but I realize that's not possible. But you could see the mesh kind of poking through right there. We can pull it back because it's actually, you know, we don't want to make a sharp corner here because there's a fillet that's going to round off there. And it doesn't work making a sharp corner anyways because it's revealing too much of the mesh here. So we'll pull this back until the mesh is just slightly poking through. I think that'll do. Okay. That's looking pretty good. Take some more measurements here. Let's find the thickness of this. About 6.5 mils there. This is quite a challenging part, actually. That's what I like. So, why this is challenging is there's like no 90-degree angles once you get past the initial square. But we can kind of like imagine how this was designed and built, and it looks like originally, you know, instead of we just extruded a square or a rectangle up this way, perpendicular to the flat face here. But what I think they did is they probably had an angled shape that they extruded at an angle. We didn't do that, but now we can do that now that we have this angle right. So I need to create all these like inset features here. And so we're just going to start at where this angled part meets the face here. Then it insets right there. So we need to figure out how much it insets. But first, let's just do a rectangle. Boom. And we just measured this distance here. Oops. I messed up here. We just measured this distance between this and this. No. What is going on? Oh. Something funny happened. So it looks like that actually makes sense. So because I did the chamfer on the sides, and then I chamfered this big slope, now these lines aren't parallel to these lines. And you can kind of see it here, like it actually is like, you know, this is a parallel line right here. All right, let me turn the mesh off. This is a parallel line. This isn't a parallel line. Which is actually really interesting because on here, it does look parallel. So what I'm going to do instead, I mean, it can't actually be parallel, but yeah, it's not. Interesting. So I'm going to have to reference this line when I measure instead of this top line, which I can do right down here. Okay, I'm still getting 6.5, so. Oh, actually, that's fine. Yeah, 6.5. So we can draw our rectangle. And so instead of referencing this line, we're going to reference this line. And we're going to go 6.5. Boom. And then do the same on this side. 6.5. Boom. Okay. Now, it basically just goes, like it's just like the opposite of an extrusion. It just kind of cuts out a block going down in this direction. So I got to figure out how I'm going to want to do that, because there's also this feature here which isn't straight. These edges here are vertical. It's a vertical cut, but this actually has a little design feature. So what I'm going to do is I'm just going to do a vertical cut for now, and I'm just going to leave some extra material at the top here, and then we'll deal with that after. But let's find out how deep this needs to go. Five mils. So -5. Boom. Great. This is starting to look like a thing, right? This is starting to look pretty similar to this. See, so we just cut out that piece, which is right there. You can see that looks about the same. This is a weird thing. I'm just like looking at it, because now, so we've just taken out this piece, but there's a further step down, and then this further step down is also at a new angle, which is frustrating. But I think we're gonna play around with this mesh again to kind of help figure that out. This part does just look like a straight up square taken out of it, so I'm gonna just measure what that square is. But see, we're pretty in line with the mesh. Something's something's different here. This is why I can't really reference the mesh too much, because obviously it's not that accurate. Like, this is a pretty drastic difference. The only way we'll really know is once we print this. Will we get... Will it be a good match? I'm just noticing, though. Just looking at this piece here. I think I might change something I did. Remember how I was saying that once we chamfered this, it made it so that this line or this line wasn't parallel with this line? But looking at it, looking at this, it does look like those lines are parallel with the outer line. So this line, this sloping line is parallel with this line, and it's actually the base line that isn't parallel with this line, if that makes any sense. It's pretty hard to explain this, I feel like, but I feel like I should match that, but then how do we do that? So this is what I'm saying, right? This, in our model, this line is parallel with this line, and this line is not parallel with this line. But on my actual piece, this line is parallel with this line, and this line is actually like skewed out this way, so it kind of goes like this. That makes it more complicated, of course. Why is that? Let's take a look at the one with the door. Let's see if that actually makes a difference. It doesn't look like that makes a difference. Doesn't look like that makes a difference, but where it is going to make a difference is visually speaking with the door. The door is nice because this is a perfect square on the top, whereas on here it's not a perfect square. So what I'm going to do, just to start, I'm going to see these chamfers. I'm just going to delete this chamfer. So I can delete it. Boom. Oh, no. It messed everything up. Why? Oh. Hold on. It made me delete all the chamfers. I deleted the wrong ones. Okay, so because it's not letting me delete this, I wonder if I can just go with a 0 slope and call it a day. Nope, it's not letting me do it. It's not going to let me delete this, is it? Oh, that's so annoying. If I go 0.1. Okay. That's pretty annoying that it let me do 0.1, which is basically nothing. But it won't let me do 0. Will it let me do 0? Can I just do 0? Nope. God. Okay, we'll work around here. I find a lot of my process is just these little workarounds. So I just changed. It wouldn't let me delete this chamfer without deleting all the work we just did. So I just made it a tiny little chamfer, and then let's see, can I just literally delete that? Yes. So a ton of this for me is just like figuring out little workarounds like that. I don't know a better way to do that, but that's just how it's gotta be, folks. Okay, so now that we got this, let me just take a measurement. So take the inspect tool here. This should be 6.5. It is 6.5. So instead, what we want is we want that chamfer to happen want it to go out. So this is something I'm just thinking about right now. What if we went... Is this 90 degrees or like really close? 87.2. I mean, that's kind of close. It does look... You know what? For the sake of just like not spending forever on this, I think we're just going to go back to how we had it because... I mean, this is a really good design challenge here. What can we do? How can we make it so it splays out? Instead. And then also, I'm just going to take a verification measurement of the inside of this. So I'm just measuring the inside of the little, the cavity we did. Getting 91.78. 91.8. Kind of a weird measurement. What are we getting here when I inspect? 95. That's too much. So, when we look at our mesh, that's actually okay. This is harder than I thought it was going to be. I'm very willing to accept that. I'm going to delete these constraints. And it was 91.8, so we can assume it's 92, I think. It's probably just like little bumps on the plastic. And we can make this 92. And obviously it's going to shrink it in that direction. But again, we can do a center line here. I think there's a way I can just center this, but I don't know. Oh. Wait, can I literally just... Can I just... No, it's not letting me grab that. Okay, that's okay. We're going to do a center line. Boom. And then coincident this. Boom. Okay. So that fits a little better. And that's more accurate to the size of this. So now, when I inspect this, I am getting 8 millimeters. And now I think what I can do is I can do a chamfer here and do it on this angle. And I can go in 1.5 mils. And then I can go down all the way. Oh, yeah, that's how we do it. And then I'm just going to do the same on this. Boom. That's how we do it, folks. Great. So now when you're looking at this line and this line are parallel. this line and this line are parallel. This line is not parallel, and that's exactly what this is like. So this is much closer, which is exciting. Oh yeah, oh yeah, look at that. It's looking a little bit better. Sorry if you can hear the wind. Okay, so let's figure out this next part. So once again, we're going to go here, and then we're going to draw a rectangle. Boom. And so now we're going to do this inner rectangle here. Sorry, the light sucks. We're going to do this inner rectangle. And I'm just going to get the top portion of it, and then I'm going to extrude it all away, I think. Not too sure, because look at the back side. It does kind of like, it's like its own little box. So that'll be easy stuff to measure. That'll give us some reference stuff. But also, I just want to get this front shape. So let's measure how big this is. I'm trying my best to like show this as part of the live streaming stuff. I'm just not that good at yet. So that's 70 mils by 52. Okay. 70 by 52. Great. Why isn't this letting me move it over? Okay, there we go. And then we're going to want to center this. Fusion guys are going to... One day a Fusion guy will watch this and be like, oh my god, what is he doing? Okay. Why did he do it that way? There's so much easier ways you can do it. I'm sure there are. I'm sure there are. Okay, good. So now we're locked horizontally, but not vertically, which is what we want. And then I want to get that distance, which is 3.5 mil. This distance, I want to make sure I'm referencing the right line. It's this line here. 3.5. Boom. Okay. I gotta hide some of these sketches. This is like, when it comes to organization, both digitally and IRL, it's so hard. And we're gonna get rid of this entirely because this whole back half is like hollow. But we don't have to do exactly this, you know? We can kind of come up with our own geometry back here because nobody's going to be looking at this anyways. All I need to do is find a spot for this pipe to bolt onto here. Like that. At this correct angle. That's the only thing that matters back here. Everything else, like there's little features that I'm sure are just injection mold points. That thing's probably a lock for the door, but we're going to have a little spring on it anyways. So I think this will be fine. Let's just continue with the top half because again, I'm going to be splitting this along this. So this little feature will get cut off and it'll be a separate piece that bolts on. God, there's stuff everywhere. getting in my keyboard. Okay. So the next thing we need to do at the top here is this little dip feature. And let me see if I can get the lighting right. Yeah, right there. So this little nook here is the channel to allow the door to swing. So I need to recreate this as best as I can. Doesn't have to be perfect. Again, I'm going to be doing a new door and everything. And the nice thing is on all three of these, everything we've modeled so far is the exact same on all three of these. It's only the part that's inside this little thing that's different. So we're going to use that to our advantage. But so I need to figure out how to do this. And what I'm noticing is there's a pretty strong profile here. Oh, shoot. There's a pretty strong profile here. You see how it kind of dips in? Kind of makes a little dip, little duck face. That's what we're going to reference to do this. I'm wondering if I can use our mesh boy for this. I'm wondering if I can use our mesh boy for this. I think first thing I'm going to do, though, is I'm going to get the measurement of... Oh, this is nice. I should point with this all the time. I'm going to get the measurement of this to this, because I know that is just like the same, that's on the same plane as this part. So once I get that, then I know there's a scoop that's going to come right there. So I just need that little measurement, and then that'll help us get started. So that is 3.5 millimeters as well, which is nice. It's the same as the last one. So let's get rid of the mesh. And once again, we're going to sketch on here. But this time, I'm just going to take a... So sometimes you have to hit P, and it projects, and it basically gives us reference points from the model. I don't know why it has to do that every time, but... So we're going to start here. See how I'm referencing this corner? Boom. Right? And then we know we're going to come to this corner. And then all we need is the height of 3.5 mils. Okay. So we have that. And then I know there's going to be a scoop feature here that kind of like goes like that. So what we can do, we can just finish this sketch, and that sketch is going to be there. And now we're going to sketch here. And what I'll do is maybe I'll turn my opacity down on the model here. Boom. Turn on our mesh. Look at that. See how this is lining up right now? So this is the line, this is the rectangle we just added right here. And you can see how it lines up really good with that scoop. And you can get, it's not a very good mesh, but it'll work. It'll work for us. It'll work for us. Yeah, and this is just like, we're going to kind of have to eyeball this. So what I'm going to do, I'm going to do maybe a 2-point circle. And again, I'm going to have to hit P so I can reference that. Boom. That line that we added. And then I'm going to do a 2-point circle because I don't exactly know where. So you can see how like I'm using this 2-point circle. What's nice about the 2-point circle is you can kind of get the diameter right and also the angle right, because it's not, you know, if this little scoop was a half of a circle, I should be able to just go parallel with this line and make it, but it doesn't look like it is a full circle. So we're going to just go with something like that. And we're just going to eyeball it for now. And then like I know I can change it after. So that's why. So let's go with that. Oh, actually, Yeah, let's do that. I didn't scan this part very well because this is the side that was facing me. So we'll see if this works. And then we're going to do a spline. And we're going to kind of like come up on this. I'm just going to draw the spline. And then I'm going to project this line here. Okay. And then we can connect this to the line. And I don't know where it is yet, but that's this is what's great about this. So we can and then we're going to need to just draw some like connecting points so we can get a full thing cut out of this. This all makes sense in a second. And then I want to definitely tangent the spline to the circle there. Now we can finish sketch. So the reason we had to add all these extra lines is so that we can actually create an object to click here. And then we're going to extrude. And we're going to add the circle that we added as well. Yes. Yes. Yes, that should work nicely. Let's just fill. I don't think these are going to matter, but let's just fill it in anyways. Now, turn the mesh off. Let's get our body. Oh, okay. The body's going to have to be transparent for a second. But we're going to pull this, and we're just going to click this face, and that's where it's going to go. And then we're going to hit OK. And then when we go to opacity control, we can make this 100% again. Look at that. We got that little duck scoop, right? That's pretty good, but it's not right yet because that mesh kind of sucks. So you can see here, look how much of the mesh we've exposed. I feel like that's too much. I feel like that's basically, you know, we're cutting out way too much, which is probably fine. We could probably get away with that. But let's see if we can get a little closer. So what's nice is you can actually change these. You know, I can drag things around. See that? Now this scoop is looking a little bit closer. So when you drag the sketch, it actually adjusts things. I'm focusing on this area here because we don't know down here if the model's like slightly skewed or the mesh is slightly skewed, but we can take a look at right here to give us a good idea. So, oops. So yeah, let's just go with that. So it's just poking through. And then, of course, here, because we have a spline, we can adjust the spline as well. This is starting to look pretty darn close to what we had. Okay, and then when we turn the mesh off, look at that, right? So we've got, let's see if I can show this. It's so hard to show on this camera. So this is what we just, this is what we just created. Right, how it scoops in and then shoop. So I think that works really nice. Now, we have a bit of weirdness going on up here. I actually think what I'm going to do is I'm going to go back to our big chamfer and just pull this back to about that point. Did that mess everything up? No, that's pretty good. Great. And so now when we add a little fillet here, it'll blend in perfectly. Okay. So I think what I'll do is instead of like designing all of these and then printing them all, I'll probably get this front piece figured out, print it, bring it over to my buddy's house. We can test it, and then go from there. And if everything fits, then we're looking pretty good. Because there's no point in doing like a ton of work if it turns out that the measurements are wrong. There's also some little parts I'm gonna have to find. Like I'm gonna have to find a rod for the door here. Right, the door's got a little rod that goes through it. It's also got this little spring here. So we're gonna have to find all these little parts. So this isn't, this isn't something that I'm rushing to do. But I think we're pretty close. So now we just got to model the door. And obviously, like, this is an injection molded part, so there's certain design considerations that they had to make that we don't have to make because we are going to 3D print this. So, thank you. I think that's a good plan, right? I'm going to need to figure out where we can actually use 3D printing as an advantage here. One of the things I want to do, I can do some designs on the front because we can make this look better. I'm modeling it. I'm modeling it. God, so many things getting on my keyboard. Okay. I think we're like basically there though on this one. I won't focus too hard on the back, but what I want to do, this is like solid right now. And when you look at the back of this, we have to, sorry, I can't see what I'm seeing. I have to make a space for a gasket here, which I could print as well, which I think is going to be really cool. I think we'll print the gasket as well. I mean, with multi-material, we could literally print the gasket right into it, which could be cool as well. Though I'm sure it's nice to be able to remove the gasket and replace them later. But he could always just get me to print him more too. So that's a thought. I want to make this inner part, or this back part, a separate piece. And ideally have it so you insert it into the front part, and just the action of bolting this onto the van will hold that back part in place. That's something I'm just trying to figure out. Like, are we going to have to kind of take... Yeah, I think we're going to have to kind of take a bit away from this gasket, so maybe doing the 3D printed gasket's actually not a bad idea because we could do a much smaller one. I'm not 100% sure on that yet. Not 100% sure on that yet. I'm going to keep thinking about that. But now that we've kind of modeled... Oh my god. I got to clean these parts before I start working on them over top of my computer. What I really wanted to find out is, now that we've got this all modeled like this with the scoop and everything, I want to see what happens if I do a shell. Because I can go with a shell like this. And, oh yeah. This is kind of looking like this, right? It's not uniform. The real one I have isn't a uniform shell. And like, this angle's all wrong. This angle's not supposed to be a 90 degree to that. It's actually, yeah, it's greater than 90 degrees. So I don't think I can do a shell yet. But you can see how that will totally work. And then obviously, like, this could be a good spot to put a gasket around here. I don't know yet. But I don't think that doing the actual shell thing is going to work just yet. We need to kind of figure out some things. So one thing I got to figure out is what am I looking at here? Yeah, this angle's wrong. Oh my god, it's actually like all of these angles are wrong. Holy. Oh, nice firewood. Firewood just got here. So I'm probably going to have to jump off here pretty soon so I can stack all that firewood. But that's okay because I think we're pretty close. Even realistically, if I printed this now, this would be enough to test this on the van. But I kind of want to play around with it a little bit more. I want to get it closer. And again, like, making this exact, wow, cool. Like, that's what I'm aiming for right now. Oh, my chamfer disappeared. That's what I'm aiming for, but it's also like super not necessarily necessary. Like, this is a functional part for a van. We want it to work. We don't need it to look exactly the same, and we could make it look cooler. So that's kind of something to think about while you're doing stuff like this. Is it doesn't have to be exactly the same. It should work. Should be able to make it work even if it's different. And it could be pretty different, technically speaking. Okay, so you know what? I'm going to model this as one piece. So I'm going to model this whole back section here, just so I can visualize this, and then it'll help me split this into two. So what we're going to do is what's the best way to do this? I need to get the right angle. So we're going to draw on this face here. And I know I'm going to need a line from this point coming down. And so, like, this is the angle that would be perpendicular to this front face. But just looking at this model, I can tell it's actually like more like this. And then this goes up at a 90 degree. And then it doesn't go directly to this corner. There's like a little bit of a gap. So I'm going to do that gap like that. And again, this is eyeballed, right? So we're going to start making some assumptions here. I'm assuming these lines are perpendicular. So that's assumption number one. I'm assuming this part doesn't really matter too much. So now, with that in mind, you can see we could start to like adjust this. And like, yeah, we can angle this. And obviously this line goes way off whack. So this has to be on this line somehow. So that'll help us figure out what we need. So first thing, I'm going to measure this line length. What's the best? That'll get us the most accurate, I think. 12. This guy is 12, which is great. And once again, we gotta bring that there. Now I'm gonna find this length. This is gonna be a bit harder to do because my calipers don't go in there, so I'm gonna use the back end again. And I really don't think I can get a super accurate measurement of this. Let me see if you can see this. Yeah, so I'm trying to measure this line here, and it's really hard to do without just basically doing this. $50, right? That's a nice round number, or is it? Yeah, it's 50, which is great. I love a round number. 12 by 50, that makes sense. Ooh, look at that. We're already pretty close. Why? Okay, for whatever reason, this is like locked in. Why is this length locked in here? Oh, because it's... No, see this line's... Oh, is it not growing? I'm going to get rid of this perpendicular constraint because that's probably preventing me from making this the length I want it to be. There we go, 50. And now we can grab this and bring it up. It's literally just like right before. I think that was just a... There we go. So now you can see this line is a bigger angle than this line, which is exactly what we want. Now we need this to fill out this space, but also none of this needs to be here. And in fact, none of this is here, right? Like we have this big chunk here. All that's gone in the actual thing. So what do we want to do? Because the pipe is going to be coming through the back, and so we got to get rid of that anyways. So what I could do for now... Just to kind of maintain this, I wonder if like I just do an offset on this. So an offset just takes our design and stretches it out, or it just gives us a bigger version of it basically. And like looking at this, I can't really get calipers on that part, but I can get them on this part to see how thick this plastic actually is. I can't really get the calipers on this part either. Okay, we're doing this. Three and a half. Oops. That's a lot thicker than it looked, than it felt to me, but that's okay. And then we can go and connect this line there. We can connect this line to there. Finish that sketch. And then we can extrude this. And I'm going to extrude this as a new body. Just because I think that's kind of what we're looking at here. So we'll go with a new body. Okay. So that's that. And then technically I could, if I wanted to, go like this and this. And extrude that 3.5 as well. Oh, the other way. And we're going to go new body. Boom. Okay, it's not going to let me do that because it's a new body. So I'm going to actually undo that for a second. Now we can get our circle measurement, the big circle. This is a pretty warped piece, so like I'm getting like 43. I think 43 mils, kind of a weird size. And then it's about 1 mil from the bottom. So we can sketch here. And I can grab a line because we're going to go from the center and we're going to go 1 mil up. And then I'm going to take my circle, 2-point circle, start from this point, and we're going to go straight up 43 mils. Boom. Okay, don't know why it's doing that. That gives us our circle. The reason I did this in another body is because now I can just like turn this off and then figure out how they interface together later. I think it is important that there is no actual seams on the inside of this door. So I need the seams to be outside just for like water retention. Or not, water proofness, I guess is the proper term. Okay, and then I know these little screw holes, they're looking like about 53. 53 mils apart. And how big are these screw holes? These look aftermarket as well, so I don't actually know if these are the proper holes. 3x4. So we'll take the center here, and we'll go 53 divided by 2. And we'll go with 4 mil. And we'll mirror this with this line. Boop. Okay, so that's the thing that our pipe, screws onto. So now I need to figure out how to interface these two. And that's the hard part, isn't it? So I think what I'm going to do here first, I'm going to get rid of this body. I need to understand that this is its own thing. Yeah, so basically if I took They share a lot of the same. I have it constrained to that angle. Yes. Yeah, I did. These share a lot of the same sort of walls, right? So like I'm thinking about filling this wall out just by like adding material here so that this can just be popped on to this part. But this also needs that wall. And so that's kind of where I'm like, how does this really go together? I want to avoid having seams, but I don't think I can avoid every seam. I think I'm going to have to treat this as like, this is where the design's going to end up changing, because I'll probably have to bump this out, you know, I guess minus 3.5 mils so that this piece can fit in there. I wonder if I could, I mean, I could print this all using sports. Oh, hi. Oh, 1 second. I'm going to come stack that in a minute. Stack that. Yeah, so these are things I'm going to have to think about. You know, before I finalize anything, but maybe what I'll do, because I need this to just slot in there. And if I really wanted to do that, then this also has to come back the same amount. Yeah, I think this is how we're going to have to do it. Minus 3.5. Boom. And then let's do the same with this. Minus. Are you finding it? Oh, and then there's there's one with a bunch of those in there. Okay. Like the sidewalls are going to work. I don't know how. I don't yet know how the you know what I mean? It's like kind of a weird, there's like two intersecting shapes here that are normally one piece, but I'm trying to make them two pieces. So I'm having to take away wall material from one of these bodies so that these can fit together. And I want to do it in a way that's not going to have like total seams. And that's the design challenge here. I want to avoid seamage. That is the design challenge here. And then like, you know, right here where this wall blends right into the corner of this one, where's the seam going to be? Is the seam here? Or do I actually cut away from this guy? I think that might be the way I have to do it. Like cut away the 3.5. Okay, let's do that, because I can go like this and go like this. Just like this is like a playground though. It's fun to just explore this. Okay, see, that doesn't work exactly. Or does it? Or does it? And then ideally I want to make it so that it's kind of modular. So all of these other ones have that same, all I have to do is change the second body. I don't have to change the surface at all. So I want to make it a modular thing. I think ultimately, though, our best bet is going to be doing something like this. And I like, when I get, nice, this should join without, yeah, okay, good. That's looking quite good. So, now we have this face, and then obviously I'm going to need to create there's a little tiny little gap there. I get into zones on Fusion 360 where I just start like it starts to feel like it's like a playground. Like I just don't really know exactly what I'm doing. So if I were to hide these bodies, yeah, so why is this not? Let's do a 3-point. Let's project. Oh, you know what? I bet if I just did that, that's probably enough. Yeah, there we go. Okay, so we could bring our bodies back. Yeah, so now I can grab that piece. I'm going to project that line as well. Great, now I can grab just that triangle. Can extrude it. We can hide this body. Bring it out front there. Okay. Now that's a good joining point. I'd like to make them like actually interlock in a nice way, so that when you put these pieces together, it just feels so satisfying. This whole backside, like this all needs to go. I guess what I can do, all of these kind of follow the same. Yeah, so this is the angle that we're working with here. Oh, this one's different. Oh, God, why is this one different? It's not that different, though. Right, this one's a little bit different. It obviously comes out way more, but it also is right to the bottom instead. This one's got a little bit of a gap. This one's the same as this one. No, it's different a third time. But what they all seem to share in common this angle seems to be the same every time. So what we can do with that is I can take this shape and extrude it out this way and remove some more of that. Right, we can remove some more of this body. And then if I hide this body, now we're left with this kind of weird thing. So let's get this to there. Just start carving away at it. It feels like it's like a block of granite, and I'm just like slowly gonna make it fit together. So now we got this little ledge, which might actually be a nice reference point for us. Maybe, maybe not. Now remember, this one doesn't go right to the top there, so we could actually probably use that to our advantage. I'm obviously going to have to print this with supports, but I want to try and avoid as many supports as possible. I think what I want to do is I want to do like kind of a sloped piece, if that makes sense. I mean, it kind of does that already, but I want to go a little more aggressive on that. You know, something kind of like, let's go 2.5. And this is precisely why, like, I could never do like a tutorial channel, because I just start getting carried away a little bit. Okay, so this is what I'm kind of thinking, right? So that little triangle we just added will be a nice, really positive sort of stop against the back of this. So we can use our combine tool, and we can cut. We'll keep our tool. We're going to cut this body with this body. Okay. So now, if you see we get rid of that, there's that nice little spot where it's going to lock into. Let me get rid of some sketches here. Yeah, so there's that nice little spot where it can lock into. Now, I don't want to have to pivot it in there. I want to be able to just slide this piece right in, and then also we're going to make some room for the wall. But I did that slope so that this, you know, this piece of plastic here isn't actually going to be that thin. It's only thin right around this edge. But it'll create a nice seam in a spot where you're not really going to notice it. And then also, I think it should, if any water does get in here, that should be good enough to kind of shed it in the right direction. Then we're going to do more of just, oops. I'm just pulling material away. Eventually we're going to end up with, like, that's a nice looking piece that like, it looks solid, nothing complicated about it, and this piece should just slide right in. This piece should just slide right in. Like vertically, I think, right? Because I think if I just did this, is there a spot I can grab this where it's gonna? No, it's not gonna let me. Okay, I think I can go like this, and then like this, and then like take that. Yeah. See, little hacks. Now I can lift this straight up, and that should lock in real nice. You can see it from this angle maybe. We're looking right down here where that piece is going to fit right in there. Yeah, that's going to be good. That's going to be good. Now we can add some walls to this. This is where I don't really know what the best course of action is. Because I don't want to have just like a random seam there. So I think what we'll do, get rid of this. Actually, let me see what's happening here. Yeah, you know what? I think we're going to take a ledge off of this, and then that's going to, okay, yeah. This is what's going to happen. It's going to be weird. It's going to be a bit weird. Like this. This should be, wait, how is that not 3.5 anymore? It's fine. Boom. Do the same on this side. Boom. Boom. And then we're going to extrude this. I'm going to extrude this back to, let me hide this body. Let's bring it back to here. What? That angle's wrong? Okay, I didn't know that. I forgot that that's the angle of that. That's not what we want. So I'm going to undo all this. instead, we'll do it on this side. We're going to sketch here. I'm going to get rid of this body. Yes. I'm going to get rid of all these other sketches because who needs them? Who needs them? We're going to project this shape here. Yes. And I'm going to draw a line from here to here, and then parallelize this to this. Yeah, and it doesn't, perfect. Yeah, see, it doesn't go right to that corner. That's why I didn't do it right to the corner. Oh my god, what? Okay. Finish, and then we're going to extrude this 3.5, join it. Okay, here's what this is going to look like, right? And I could just like maybe do some mirroring or whatever, but that's just going to be easy enough for me to just do this exactly the same on this side. Sometimes it's faster to just do it the exact same. Again, we're going to go to this bottom one, and then we're going to parallelize these. Finish, extrude 3.5. Boom. So now this guy fits again. It's missing some walls, but that's okay. Because we're going to sketch on this wall, and I'm going to project that line and that line. Okay. And then extrude 3.5. Just disappear this body for a second. Oh, and we're also going to do this. Boom. Yes? See that? That's kind of a weird shape. Isn't that a weird shape? But it's going to mesh so nice with this, I think. It's going to mesh nice with this, I think. Ah, did I just... I think I just made this so much harder for myself, though, because... either way, I'm going to have a weirdly angled thing. I shouldn't... like, is it worth just printing this all in one? Like, this one, I think it would be worth it, because that would be, like, minimal support material, but... I don't know. I'm really liking how this is, like, a modular thing. Because then we could, add a bunch of other stuff. Like, let's say he wants to use a different hose adapter or something. We can make it really easy to adapt these. Let's just keep going on with what we're doing. Let's not stop second guessing ourselves, Boom. We're doing the exact same thing again. Okay. And then we're going to extrude. Oh, and that. Okay, that's what we actually want here. And that's a much nicer looking part, I think. Because right now this part prints flat on this surface, which is really good. But again, this doesn't really... I mean, I could just screw them together, but I don't really want everything to be supported by one screw. I think we might start with that. I got to go stack some wood anyways. I'll print these two pieces because I can print this guy flat against here. I can print this guy flat like this. And I'll just do like a whatever infill or whatever because it's like way more solid. Just so we can test it to see if it's fitting. And then I'll figure out how to properly join these two. Because the issue is like I could have this inner piece just screw into this piece. But this is like there's going to be a plug there. So people are going to be constantly like jamming stuff into there. And so if this is just screwed onto there, I don't know, I don't want that to come loose. And so initially I wanted to basically split this design. Okay, this was my other idea. We're gonna just do one more thing here. This is my other idea. I'm just copying this. Okay. Because I'm going to combine these two. Okay, so now this is one solid body. And then I was thinking about doing... How thick is this again? 7, I think, so minus 3.5. I was thinking about doing something basically like this, where you split this body right down the middle. And why I like this is because you end up with, two halves that can be printed flat, and then one set of screws to mount it. But the issue is it splits the hole in half. The big reason is because this way you could print flat, but it splits the hole in half. Which honestly wouldn't be the worst for this. Because I could just have a face plate. But the other ones aren't going to be so simple. Because that's actually like, that might not be so bad. Because what I could do is then I could just have it so that when they are together, bolted on, I just print a face plate that fits on there. And then when you screw through there, holds the faceplate in place. But this feels weaker to me. So I don't think there's a good way to split this where you can print, where you have two halves that can be printed without supports. This version here, obviously you can print this body part flat. But this guy, it prints flat like that, but if I want it does look weaker, right? Yeah, that's what I'm thinking. So it's better if this stays in one piece. And like realistically, again, this isn't too bad. I could print this all in one piece and that might actually be perfect. But these ones get a little crazy with how much is actually sticking out the bottom. But it might not be that big of a deal. It's just you end up with, like, do I print it like this? I want them all to be the same, right? So ideally I print them all flat. I print them all like this. And so this all needs to be supported. And that would be nice, because then you get a nice, like, well, I mean, you get a solid looking surface here. These parts are going to obviously have the 3D printed little things, but you get a nice surface here. But once we get into this guy, it's like that's like so much support material, which is fine. It's not a cost issue. It's not even a time issue. It's just more of like a personal issue. Like I just personally don't love that. So that's kind of, that's kind of the thing I'm trying to figure out with these. Is there a way I can do this? I guess I could have it so this part, yeah, I don't know. I'm gonna have to think about it. I'm gonna print these two pieces, and that'll at least get me sort of, I'll be able to put it in my hands, and then I can actually like think about it better. So I'm gonna do that, and yeah, I think that's pretty good for today's stream. Thank you so much, Depressed Banana Bread Official. It's super cool that you're here. I think you might have been the only person here. I love banana bread, so don't be depressed. Banana bread is amazing. Thanks so much. I appreciate you being here. It really means it actually means the world. It's super cool. I'll be here next Wednesday, I think. I'll be doing more design work. But if you want to come on to the music streams as well, I do those Monday and Friday, so I'll be doing a music stream tomorrow. I had to shift today's stream to Thursday, but normally I'm trying to do these ones on Wednesday. So appreciate it. Thank you so much for being here. I will see you hopefully next time. Thanks so much.